Hello everyone. In today's session, we are going to talk about law of exponents, which is one of the very important topics so far as number system is concerned. Right? So we'll start off with law of exponents. Now let's try to understand the basic rules. If I have a square into a cube into a raised to power 4, that can be simplified like this. Alright? The powers of the bases, they can be added up. Okay? Next is, if I have 1 upon a, that can be written down as a raised to power minus 1. Next, if I have a raised to power 3 upon a raised to power 2, that can be simplified like this, which becomes this. Okay? Then next is, let's look at this. A square into a square into a square. This can be written down as a raised to power 2 plus 2 plus 2, which is equal to a raised to power 3 into 2. Or it can be also written down as a raised to power 2 into 3, which can also be written down as a raised to power 2 whole raised to power 3. Alright? So what we understand from here is that if you have a raised to power m and whole raised to power n, this becomes a raised to power m into n, which is a raised to power mn. Alright? Now, along with that, people normally get confused with another rule. Okay? So, for example, if we have 2 raised to power 3 raised to the power 2, and we have 2 raised to power 3 whole raised to power 2. Now this value is equal to 2 raised to power 3 into 2, which is equal to 2 raised to power 6, while this is equal to 2 raised to the power 3 raised to the power 2, which means 2 raised to the power 9. Okay? So if you compare this and this, okay, this becomes greater than this, or rather this is not equal to this. Alright, so be very careful. Now if I take an extension of this further, I can have 2 raised to power 3 raised to power 4 raised to power 5. And if I try to raise it to the power 6, now in order to solve this, what we have to do is, let us take this power as k. So this becomes 2 raised to power k whole raised to power 6. This is equal to 2 raised to power 6k, and this is equal to 2 raised to power 6 into 3 raised to power 4 raised to the power 5. Alright? And let's talk of one more rule, and that is, if we have 2 raised to the power 3 raised to power 72, this can be written down as 2 raised to power 3 into 3 into 3, 72 times. Alright. Now, I can, if I put my bracket out here, it doesn't change the problem at all. And now this I can evaluate beforehand, and I can write it down as 8 raised to the power 3 into 3 into 3, 71 times, which becomes 8 raised to the power 3 raised to the power 71. And if I put my bracket here, then this gets reduced to 2 raised to the power 9. Okay, and then this becomes 3 into 3 into 3, 70 times. This is equal to 512 raised to the power 3 raised to the power 70. So what we have worked out is that 2 raised to the power 3 raised to the power 72 is equal to 8 raised to the power 3 raised to the power 71 is equal to 512 raised to the power 3 raised to the power 70. And this can be further converted into other forms or other values, as the case may be. All right. Now, let me take some basic problems, okay, in order to digest these rules. All right. Okay. So I'll take up a couple of problems, okay, and I'll write down 243 raised to the power 0.13 into 343 raised to the power minus 0.2 upon 243 raised to the power minus 0.07 into 7 raised to the power 0.25 into 49 raised to the power 0.075. Now let's see how to solve this. So try to convert these numbers into the basic powers, and if possible, try to make the negative powers as positive powers, and then do the simplification. So this is what? 3 raised to the power 5 raised to the power 0.13 into this will bring down to, in order to make this negative into positive, and this will push upwards, right? So I write it down this as 3 raised to the power 5 raised to the power 0.07 divided by, this one is 7 raised to the power 3 raised to the power 0.2 into 7 raised to the power 0.25 into 7 raised to the power 2 raised to the power 0.075, which equals 3 raised to the power 0.65 into 3 raised to the power 7 5 is 35. All right, divided by 7 raised to the power 0.6 into 7 raised to the power 0.25 into 7 raised to the power 0.150, which is equal to 3 raised to the power 0.65 plus 0.35 divided by 7 raised to the power 0.6 plus 0.25 and plus 0.150, and this whole thing is equal to 3 by 7. All right, let's take one more example. A raised to the power 5 square root of b into a raised to the power minus 1 and 4th root of this, and take the cube root of this whole thing divided by a square into 5th root of ab cube, and this square of this whole stuff, and this is equal to a raised to the power m b raised to the power n. What we have to find out is find the value of m by n. Okay, so let's see how to solve this. So once again, what we have to do is segregate the powers of a and b and then equate them accordingly, right? Okay, so let's do the segregation part. This is a raised to the power 5, it should be divided by 3, so 5 by 3. Then look for other powers of a raised to the power minus 1. This gives you a raised to the power minus 1 upon 4 into 1 upon 3. So that means minus 1 upon 12. And then this is a square, it becomes a raised to the power 4. When it goes up, it becomes a raised to the power minus 4. So minus 4 by 1, let us put it that way. And then this is what? A raised to the power 1 upon 5. This becomes a raised to the power 2 by 5. So this is minus 2 by 5. Alright. And similarly, we can put b raised to the power how much? 1 upon 2. This is 1 upon 6. And then this is b cube. This is 3 by 5. And this is 6 by 5. And since we are taking it on the upper side, so minus 6 by 5. Alright, we can take the LCM also of these values. So LCM for this is 60. So this is 20 into 5 is 100. Minus 12 into 5 is 60. So minus 5. This is 60 into 4. Minus 240. And this is 12 to the 24. Alright, and this becomes what? 30 LCM, 6 5 are 35, and 5 6 are 30, minus 36. So this gets simplified to, this is a raised to the power, and this is b raised to the power. So this becomes a raised to the power how much? 100 minus 240 is 140, 140, 164, 169. A raised to power minus 169 by 60, and this is b raised to power minus 31 by 30. And this is equal to a raised to power m, b raised to power m. Now equating the powers of a and b separately, what we have is m by n is equal to minus 169 divided by 60 over minus 31 divided by 30, and this is 2 times, this becomes, and this is also cancelled out, this makes it as 169 over 62. Alright? Okay. And now let's talk about let's take up one more problem. Okay? And the problem goes like this. 27 raised to power 3 raised to power x equals 3 raised to power 27 raised to power x, and find the value of x. Alright, so we can start from LHS or RHS. Let's say we start from LHS. This is equal to 27 raised to power 3 raised to power x. Now we know that this base is 3 while this is 27. So let's convert this base into 3. This is equal to 3 raised to power 3 whole raised to power 3 raised to power x. This can be multiplied with this. This becomes 3 raised to power 3 into 3 raised to power x. This is equal to 3 raised to power 3 raised to power x plus 1. Alright, and this is equal to right hand side 3 raised to power 27 raised to power x. Since these two bases are the same, we can say 3 raised to power x plus 1 equals 27 raised to power x. Now since this base is 3, we need to convert this 27 into base 3. It is equal to 3 raised to power 3 whole raised to power x, which is equal to 3 raised to power 3x. And now since both the bases are the same, we can compare the exponents. This implies x plus 1 equals 3x, which implies twice x is equal to 1, implies x is equal to 1 by 2. Alright, and now let's talk about comparison of numbers in exponential form. Okay, and before we do that, let's try to understand the rules of the game. So, comparison of numbers in exponential form. Alright, so let's look at the rules. The first one is that, so if we have the numbers of this type, a raised to power b and c raised to power d, and we need to compare these two numbers. So what do we have to do? The first rule could be, we can make their bases same, and then compare the exponents. That's the first rule. Another way could be, we can make the exponents same and then compare the bases. And third could be, we can compare the bases as well as the exponents. For example, if we look at these two numbers, and if we can say that a is greater than c and b is greater than d, then definitely we can say a raised to power b is greater than c raised to power d. And let's look at the fourth rule. If you have the numbers a raised to power b and b raised to power a, and we want to compare them. Now the rule is that if a and b both are greater than or equal to 3, okay, and A is less than B, then A raised to power B is always greater than B raised to power A. For example, 3 raised to power 5 is greater than 5 raised to power 3. 5 raised to power 17 is definitely greater than 17 raised to power 5, and so on. Okay? Let me take a couple of examples. So if I say 2 raised to power 8 and 8 raised to power 2, which one is bigger? So if you look at this, let's make the bases same. This becomes what? 2 raised to power 3 raised to power 2, which becomes what? 2 raised to power 6, while this is 2 raised to power 8, and hence this is greater than this. If we take another example, 2 raised to power 300 and 3 raised to power 200. Okay, so what kind of transformation can we do in these two numbers? What we can do is 2 raised to power 3 raised to power 100 and 3 raised to power 2 raised to power 100. So in this case, what we have done is we have made the exponents the same, and now we can compare the bases, right? If the exponents are the same, the bases become what? 8 raised to power 100 and 9 raised to power 100, and definitely the relation goes like this. If you take another case, let's say 8 raised to power 999 and 9 raised to the power 888. Let's compare these two numbers. So what do we do out here? What we can do is we can convert this to 8 raised to power 9 whole raised to power 111, and this 9 raised to power 8 111. Now these exponents are the same. Okay, we have to compare these two numbers, and we have already talked about this in the rule number 4. That's this number will be bigger than, this base will be bigger than this particular base. Hence, this is greater. Alright? Similarly, we can talk about one more example. And it goes like this. Let's say 8th root of 8 and 9th root of 9. Alright? So how do we go about solving this? The very first thing would be put them in the exponent form. 8 raised to power 1 by 8, 9 raised to power 1 by 9. Now the relation doesn't change between two numbers if we raise them to the same power. So whenever we have got fraction powers, the rule of thumb is take the LCM and raise to the power of the LCM both the numbers. Okay? So 8 and 9, 72 is the LCM. So we can raise them to the power 72 and 72 here. So it becomes 8 is power 9 and 9 is power 8. And you know by rule number 4, that's the relation between the two. Alright. Alright. Now let me talk about, to sum up this particular topic, okay, let me ask you a general problem, a very general problem, which can use probably all the rules that we have discussed so far. So let us say we have the numbers 3, 3, 3, 3, 3, 3, 3 raised to power 3, 3 raised to power 3, 3, 3, 33 raised to power 33, then 33 raised to power 3 raised to power 3, 3 raised to power 33 raised to power 3, 3 raised to power 3 raised to power 33, 3 raised to power 3 raised to power 3 raised to power 3. Can you find the largest number among these 8 numbers? Okay? So how do we go about it? Now it's a comparison problem, and comparison problems are relatively easier because we have to keep deleting the numbers which are smaller than the other number that you are comparing it with. Right? So as you can see, most of these numbers will be more than a mere 4-digit number. We need to talk about it. Hence, I can straight away delete this number. This is the smallest number. Alright. Similarly, 333 raised to power 3 will be a finite digit number, maybe probably 8-digit number, while this will be a very large number. So as compared to this number is very small. I can delete this. Alright. Similarly, if you look at these two numbers, this makes power 27, while this power is 33. So this number is smaller than this number. I can delete this. Alright. Similarly, if you look at this, this is 27, while this is 33. As compared to this number, I can delete this. Alright. Similarly, this is 33 into 33 into 33. While this is 3 raised to power 33, which is a very, very large number. This power is very, very large as compared to this. So I can say this number is much, much smaller as compared to this. I can delete this number. Alright. So finally, what we are left with, 3 raised to power 3, 3, 3. Then 33 raised to power 33. And then 3 raised to power 3 raised to power 33. Alright. Now, this number, 3 raised to power 333. Well, this is 3 raised to power 3 raised to power 33. This number is much, much larger than 333. Hence, I can delete this number. So finally, I am left with these two numbers to be compared. Right? Now, let me do one thing. Let's try to recall rule number 3, which says a raised to power b, c raised to power d. If I can prove a is greater than c and b is greater than d, then definitely I can say a raised to power b is greater than c raised to power d. Let's try to apply that here itself. So, what we can do is, let us write down this number as 3 raised to power 3 into 3 into 3, 33 times. Okay, let's say I put my bracket here. This becomes what? 3 raised to power 9, and this is 3 raised to power 31. Now this number is very, very large as compared to 33. Let's say I denote it by L raised to the power 3 raised to power 31. Okay. So now I know that this L is more than 33, and this 3 raised to power 31 is much, much larger than this 33. So definitely I can say this number is greater than this number. Hence, this is the largest number, and that's my answer. And that's the end of today's session. Thank you.